Hello, everybody. I hope everybody is doing fine and healthy. Everything is good. Okay. I don't think right now there. ah, Great. Let me check. Just the voice is coming or not, because I don't think audience is here. I don't know why this is the scenario with the English channel so far. Maybe we are working better. We are working harder to get more and more of you guys attention. So we have differential equations today, a topic from class 12th. These are some remaining topics I'm trying to cover up for the 2025 aspirants, so that they can get help as much as they need, as they require. Hi, Saujanya, how are you? All good? Having fun? Great. Nice things, nice. The winters have started. Don't sleep too much. For the students who are in class 11th or beat in class 12th, both of them, you have to avoid the winters of this year and another. I know that it's very difficult to wake up early or even wake up during the winters, but only these 2 years are the years which will decide our fortune, our future as well. So stick tight. The requirement of the time is to work hard right now. Please keep working hard, keep your goal determined and in front of your eyes. Don't lose the dedication, don't lose the hard work. That's all I would like to say. And yeah, so not many we have. I don't think people have come so far. Whoever is there on the channel, one kind request that I have is please like the session and subscribe the channel. More you do this, better chances are there for us to continue working better and better. We also need motivation, as you guys do need motivation for studies. We guys need motivation for working in better direction, in better ways. So if you're there, if you come on the channel, keep liking and keep subscribing. If you haven't subscribed so far, I would request, please subscribe the channel. We are coming up with much better things, especially for 2026 aspirants. For 2025 aspirants, we are trying to do as much as possible till their first attempt. But for 2026 aspirants, we are on a better scale. We are on a better direction for them to, for them to score better. So class 11, limits and derivatives. Cadets, yes, limits and derivatives is going to come soon for class 11 also. Limits is there on the channel. Continuity and differentiability is there on the channel. Derivatives are also there on the channel. For maths I'm talking about. And tomorrow, don't forget, tomorrow we are going to do a very good and very productive session which will be of straight lines, and in that we are not going to study any theory. Theory is already taught on the channel last week, and this week, I mean tomorrow, we are going to completely solve all the questions, all the PYQs. I'm not saying important or non-important, all of them, starting from 2024, starting from 2002 to 2024, all the PYQs. See, if you do this much, there is nothing else you require in a chapter. I know many of the influencers or many of the people, I'm not talking that they are saying wrong, but I'm saying we have already started JEE 2026, guys, and I'm saying that if you cover up all the PYQs of last 15-20 years, no, that's the preparation. It's not just 5 years. Many people will say that just do PYQs of last 5 years and that's enough. I won't say that. I don't recommend that, and I think anybody on the channel or anybody in the Unacademy itself would not suggest that as a correct approach. We might say sometimes because of the lack of time, but the correct approach, if you are preparing for JEE 2026, concept clarity is important, one thing. Second thing is the PYQs. See, how many ever books you solve, How many ever questions you solve. That won't give you as much of practice compared to the practice which will be given to you by previous year questions. That previous year questions of last 15-20 years, if you solve for every chapter, no, I'm betting you nobody can beat you in the chapter, be it JEE Mains or be it JEE Advanced. You can clear all of it. And see, these 2 years only you have to create a fortune out of your life, and create a good life for yourself. Clearing JEE definitely embarks a milestone, a important milestone in your life. It's okay, many people say that there is so many things, there are so many things apart from JEE also. Why to just get into IIT? Aren't there another colleges? But I would say there are other colleges also. But why IITians are renowned so much, or why IITians are always looked in a different way, because they have proven themselves at the very distracting ages of their lives. 11th and 12th, most distracting age. But you have to prove that you are away from distraction, you are into your goal, and you once prove that you are capable of achieving your goal, everybody will believe in you. If you don't, then life is not same for everybody, huh? All right, so differential equations. Before differential equations, I'd like to once more put your attention towards this All India mock test for JEE 2025. If you are a JEE 2025 aspirant, I would say enroll this. The link is there in the descriptions of today's session. This is going to be a game changer. It is very important right now at this moment, when your JEE exam is just 30 days far, not even 30 days, I think, right? 30 days far. This time, if you do this, this will change your game. This will tell you what type of questions you need to prepare. First of all, where are you staying? Which level are you at? Your rank among a lot of students from who are enrolled with Unacademy or who are enrolled with this mock test series. So enroll yourself for this. This is definitely going to be proven as a game changer for you guys. Trust me. If you're 2025 aspirants and if you're not giving mock tests, then you're losing a lot in your game. This thing is very good, very efficient. I would seriously recommend, if you're watching a video or watching this live, go for this. Go for this. It's not even very expensive or anything, but enroll, and enrolling link is there. I think it's for Unacademy enroll students, or for some specific categories this is even free. You can check all the details in the description, in the link which is there in the description. So do click that link and go for it. And please, once again I'll say that if you're coming on the channel, please like the session. Do not forget to like and subscribe. This matters for us. All right, differential equations, guys. If you are good at differentiation and integration, then this chapter is very normal and very easy peasy for you. It's not going to bother you, right? It's application of differentiation and its application of integration, also combined application. Weightage, if you talk about, weightage is very, very good. Many things are not included. Some things which we are going to do in this lecture today might not be included in main syllabus, but in advance it has a lot of importance. Only in 2020 there was no question in advance. Otherwise in mains you can always expect at least one question, at least one I'm saying, at least one question from differential equations. So this chapter you should prepare. Even if you are, even if you have lack of time, I would recommend that watch this lecture and prepare yourself for this chapter. Who knows that you might be able to get one correct answer and 4 marks over here. Okay, in mains, if you can attempt one question from differential equation correctly, you get 4 marks, man. Attend this lecture, try to understand what the chapter talks about, and it will be beneficial for you. Just a minute, let me check the volume. Okay, so this one chapter can create a lot of difference in your marks. Okay, A lot of difference in your marks. One more thing, for 2026 aspirants, sir, which playlist derivatives are there? Class 11th K-edits, it will be there in class 11th topics. Differentiation, the name is differentiation. Okay, go through that lecture and understand the main methods of differentiation. That'll be it. Okay, it's there in class 11th topics. There are certain class 11 JEE type something like that. I'll just check. Class 11 JEE on the same channel. Differentiation is there. There all the derivatives are taught. Limits is there. Differentiability is there. Continuity is there. But first do derivatives. First do differentiation. Okay, great. All right. So I hope nobody is forgetting to like the session and subscribe the channel. Order and degree. Few topics. First, let me make you go through the topics. What all is there in this chapter? Very small, not very big chapter. Small chapter, small. I can say very few topics are also there. Mainly, this chapter is about application of integration and differentiation. If you are good at differentiating and integrating, then this chapter is a cup of tea for you. Is a cup of tea for you. Not a problem at all. Order and degree of differential equation. Very small topic, but not in JEE Mains. I have not seen any question in Mains which is specifically about order and degree. But yeah, in your ComDeck, Comet K, or in exams like VIEEE or other, or even boards. In boards, there can be definitely questions from this particular topic. Very important and critical topic. Then formation. Second thing which we need for, as once we understand about order and degree, then we'll understand how to form a differential equation. Third thing we need to understand is solution. And very good thing that although the order and degree of a differential equation can be 2, 3, 4, 5, anything. But in our syllabus till JEE Advanced also, we have only first order and first degree differential equation. And major topic of this entire chapter is to be able to find the solution of differential equation. How to find the solution of differential equation. Now, what is a differential equation? What is a differential equation? Equation which involves derivatives. Differential equation, I'm just writing DE for that. Equation that involves derivatives. That means dy by dx or dx by dy. That's it. Obviously, the sentence itself makes it clear that a differential equation can be nothing but equation in derivatives. Normal linear equation, quadratic equation are equations in variables. Correct? Differential equation is also an equation, but equation in which involves derivatives. That's simple to understand by the definition. All right, great. The most important, or the very first important thing which we need to understand for understanding the chapter of differential equation is the degree and the order of differential equation. What do we understand by the degree and the order of differential equation? Now here, if we talk about, in these topics also, if we talk about mainly or most importantly, the questions come from the solution of differential equation. It's not written here, but yeah, solution of differential equation, that means this part, right? Different forms of differential equation and finding the solution. That part is important. So that will come to, but before that, first we'll understand few things which we need to understand and be very clear at, we be very transparent at for solving the differential equations given to us. So sometimes students directly skip these topics at order and degree. This is very simple, okay sir. No, understand this thing also very carefully. What do we mean by order or degree? Now order means how many times, maximum how many times a dy by dx is done, or the entire function is derivated. That's it. For example, if I have in an equation which is something like this, dy by dx plus x plus or directly equal to some c. Okay, we have differentiated maximum differentiation, maximum order of differentiation. That means first derivative, second derivative. These are orders of differentiation. So maximum, what is it? 1 only. Now if I do 2 over here, then 2 times I have differentiated. So order becomes 2. right? That way we have to understand it. Now suppose if I have d3x by dx3 and I have dx by dy d3y, and here suppose I have dy by dx, and then some more things are there and equal to something. First of all, this is a differential equation because it involves derivatives, and in this also order will be 3, maximum order. That's the order of a differential equation. Let's understand more as we move ahead, right? Let's understand more as we move ahead with some examples. Order means what? Clearly from definition, vector algebra chapter, Syed Roshan, yes, I forgot that you had commented that before. Vector algebra, see, vector is completed on the channel. I know what you're talking about. Vector algebra, equations of which involving vectors. In basic maths we can do it, or okay, Syed Roshan, I'll keep this in mind, beta. I'll keep this in mind. I'll see that how I can involve it somewhere. Vector algebra not very big also. We can teach it somehow, right? You are appearing for 2025, Syed Roshan? Are you appearing for 2025? Come on, reply to me. Or you're talking about this for 2026? Yes, 2025 na. Don't worry. By end of December or start of January max, I'll take that. Beta. I understand that's an important chapter. I'll take that. Okay. Don't worry. Order, what do we mean by order? Understand it carefully. What do we mean by order of differential equation? Order means, first let's read it. It is the order of highest order differential. Simply highest order differential coefficient. Differential coefficient means whether we have dy by dx, we have d2y by dx2, d3y by dx2, highest of them is the order. Now sometimes how students get confused, sir, dy by dx, these two things are not same. Dy by dx to the power 2, is this equal to d2y by dx2? Are they equal? Many times, I know you guys don't do that, but I'm just explaining for somebody who's actually thinking that these two are same things. Sometimes, yeah, that can happen. Okay, no, these are two different things. Okay, these are two different things. Here dy by dx is multiplied with itself twice, and d2y by dx2 means we are differentiating two times. Right? So d2y by dx2 is the order over here is 2, but here order of differentiation is 1 only. In this one, order of differentiation is 1 only. Which is the highest order now? Highest order is 2. Even if this power is 100, no, still the order of this differential equation will be equal to 2 only. And you can see differential equation means equation which involves derivatives. That's it, right? Keep liking the session if you are here on the channel. Don't forget to like the session. Now, order means highest order of derivative used in that particular equation. It does not matter what power of derivative we have. Power does not decide. Order means d2y by dx2 means we have differentiated twice. Understanding this might look very easy. We know, sir, we have studied this in school also. But many times this actually, knowing the order actually makes you think of solution for many problems where constants are involved. Arbitrary constants. If you have read that, then there you'll understand what is the importance of order also. Here, what is the order? Sir, d2y by dx2, second order. Sir, dy by dx to the power 1 by 2. Order is 1 only. Order of derivative over here is 1 only. What is the order of derivative here? 3. What is the highest order of derivative used? 3 is the highest order of derivative. So order becomes 3 over here. That's simple to understand. Okay, the order becomes 3 over here. So don't make the mistake of deciding the order by looking at the power of the derivative. No, power is 4. Order, highest order derivative which we have used is 3. 3 times differentiating, 1 time differentiating, 2 times differentiating. That means order. So order of derivative is 3. Maximum order is 3. All right, let's move ahead. Now, okay, this is now degree. Order is not a problem. Now, order will never be a problem. Order will never be a problem. Just look at all the derivatives used, all the dy by dx used, and just pick the highest of those, highest order of those, and that will be the order of your differential equation. For example, if I'm just simply writing d3y by dx3 plus e to the power of d4y by dx4 equal to 0 or plus c some plus x or plus c something equal to 0. Here order will be 4 because highest order highest order derivative used is this thing. Order will be 4, but degree will be different. Degree is sometimes peculiar and sometimes tricky to understand and to know. Now first read. Okay, I know definitions, even I don't recommend doing the definitions, but when you come at definitions, reading the definitions gets stuck in your mind, so don't avoid the definitions also. It is the degree of highest order derivative occurring in the differential equation. Highest order derivative, degree of highest order derivative. Simple words, degree of highest order derivative. Degree means power, but there is a condition. After it has been expressed as polynomial in derivatives, first your entire differential equation should be in the form of a polynomial in derivative. Polynomial means what? We have studied in 9th and 10th also. Polynomial means every term, in every term, the power of the variable should be a whole number. What does a polynomial mean? A polynomial means that in every term of the expression, if power of the variable is a whole number, then that is a polynomial. Here equation is in derivatives. Differential equation means equation in derivatives. So here polynomial should also be in derivatives. Polynomial in derivatives means that every term, in every term, the power of the derivative should be a whole number. In every term, power of derivative should be a whole number. Power means degree of derivative should be a whole number, and in those highest degree means the degree of entire differential equation. Let's understand it with the help of some examples. For example, over here, okay, now dy by dx first order, d3y by dx3 third order, d2y by dx2 second order. Highest or degree of, understand the equation, remember, try to recollect the definition once again. Degree of highest order derivative, degree of which is the highest order derivative here? So d3y by dx3 is the highest order, and degree of highest order means 2. So here degree will become 2. But before doing this, make sure, is this a polynomial in derivatives? Sir, here also derivative to the power 4 whole number, derivative to the power 2 whole number, derivative to the power 1 whole number. Powers of all the derivatives is a whole number, so it is a polynomial in derivatives, not a problem at all. Directly we can say degree 2. Now look over here. Look over here. Is this a polynomial in derivatives? Is this a polynomial in derivatives? Sir, here derivative is on e. Sir, does that make it a polynomial in derivatives? This is not a problem. This is not a problem. But looking at this, acha, if this term was not here, if this term was not here, suppose for example, let's say is this term is not here, then what is the degree? 2. Degree is 1. Power of the highest order derivative, power of derivative is 1 only, right? Degree will be 1, but this term is here. Now this term does not allow this equation to be a polynomial in derivatives, because if you look at the expansion of e to the power x, e to the power x expansion, if you remember, in the limits chapter we have discussed these, and in binomial also, no, in limits we have discussed 1 plus x square by 2 factorial plus, it keeps going on like that, right? X cube by 3 factorial. So it is an infinite series. Expansion is infinite. In polynomial we have finite terms, so this is obviously, this is not a polynomial term. Obviously this is not a polynomial term. If this is not a polynomial term, then we don't have an equation which is a polynomial in derivatives. Polynomial in x means in all the terms the power of x should be a whole number. Polynomial in derivatives means in every term the power of derivative should be a whole number. Here power of derivative itself we are not able to understand. So here what we will say, degree is not defined or undefined degree. Right? Degree is not defined. Do not forget to Like the session please. If you are here on the channel, on in the session, do not forget to like it please. That matters to us. Okay, now if simple thing what we just now discussed, if your differential equation cannot be expressed as a polynomial in derivatives, that means definitely its degree cannot be defined. Sir, only one term was not was not able to be expressed in derivatives, or was not able to be expressed as a polynomial term. No, that does not matter. Even if single term you don't have a polynomial term, that means you cannot define the degree. Here we cannot define the degree because the definition itself says after it has been expressed as a polynomial in derivatives. If you are not able to express your equations as a polynomial in derivatives, so you cannot define the degree. Simple thing, you cannot define the degree. Okay ji. Now let's move ahead. Let's find some questions. First we'll develop our basics, then we'll move towards, then we'll jump or dive into the main parts of the chapter which will help you for your exam, JEE exam. Let's find the order and degree of the following differential equation. DE means differential equation, by now you are sure. Sir, order of, acha, here some adjustment obviously we'll have to do. So here what we can do, sir, d2y by dx2. Sir, this is 1 by 4, so here I'll do 4 equal to y plus dy by dx. Great. What is the highest order derivative? dy by dx or d2y by dx? 2. d2y by dx2, highest order derivative and its degree. Is it a polynomial in derivatives? Yes sir, it is a polynomial in derivatives. Here the degree is 1, here the degree is 4. Highest order derivative is this and its power is 4. So degree is 4. What is the order? Order, highest order derivative is d2y by dx2, so order is 2. Be very clear in this also. Be very clear in this small thing also. Don't mess up here. Okay, in this small thing also you'll have to be very clear. Just a minute. All right, let's move ahead. Any problem? You can look at it, solve it once. If you are reading this chapter for the first time, this part will play a major role. Okay, don't take it lightly. Now let's find the order and the degree. Tell me what will be the order and degree in the chat box if you're there. Tell me what will be the order and degree in this particular differential equation. What will be the order and the degree? What will be the order and the degree in this particular differential equation? Anybody? Syed Roshan, are you there? No? Is this a polynomial? Sir, e to the power derivative. Sir, not a polynomial. Log or e to the power, in log if you have derivative, or in e to the power you have derivative, that means it's not a polynomial in derivatives. So degree we can directly say not defined, nd or nde, whatever, right? And what is the order? Acha, order, for order does not, order there is no problem. Know it that for order will always be defined. Degree can be defined or not defined, but order will always be defined, because order definition is simple. Which is the highest order derivative used over here? So order is 2 here, order is 3 here of derivative. So order, maximum order means 3. Maximum order, which is 3. That's it. Okay. Degree is not defined because, why? Because we don't have a polynomial in derivatives. So degree is definitely not defined over here. Alright, let's find the order and degree of the following. Okay, one more is there. Great. Ln of dy by dx. Acha, here can you do something about, can you do some adjustment? Can you do some adjustment? Can I write like this, dy by dx? Not always, not all. In the previous one we cannot do any adjustment. In this, what we'll do, even if we take log, inside log we'll have dy by dx. So that also does not make it a polynomial. But here adjustment is possible. Here what we can do, this can be written as e to the power x plus 2y. Sir, but x and y are not, the powers of x and y are not whole numbers. This is not a polynomial term. Arey, this is a constant term then. Our polynomial, our differential equation is in derivatives. Our differential equation is in derivatives. Hi Vineet, how are you? our differentiable equation should be in derivatives. This here, not a problem. All the derivatives are polynomial terms. dy by dx polynomial term. This might be some constant, not a problem at all. Okay, so this is a polynomial. Directly by looking at ln and derivative inside ln, we cannot decide that it's not going to be a polynomial. This is a polynomial. Here, what is the degree? The degree is 1. What is the order? Highest order 1. One derivative only. Highest order 1. Degree also 1. Order and degree both are 1. Not a problem at all. Okay. Okay, these are same questions only. Great. Let's do some more to build this concept. See, building this concept in the starting is very, very important. Don't chuck this. Okay, dy by dx minus x, something will be given to you, order and degree. For first one, if we talk about, how can we write it? Dy by dx. Okay, now, okay, wait. Can we define the degree over here? Yes, we can. So dy by dx minus x. Let us, without even completely solving, we can look at the degree. For degree, we don't have to solve or anything. This is 1 by y minus x dy by dx. Acha, order to you can say directly, no? Order you can say directly. Highest order derivative, both are dy by dx. Order is 1. So order, I am directly writing order, there is no problem. Order directly you can judge. Order is 1. What will be the degree? Acha, this will get multiplied with this. That means we are going to have dy by dx minus x multiplied with y minus x dy by dx. Order 1, highest order will be 1 only, highest order derivative will be 1 only. But what will be the power of dy by dx? When you will solve this, what will be the power of dy by dx? This is 4. Power of from here we'll have power 4 multiplied with this will give us power 5. So degree, do you agree that we can write it will be equal to 5 and nothing else? Right? The degree is going to be 5 and nothing else. Correct? So degree, you don't have to, for degree, just look that what can be the highest power of highest order derivative. Highest order derivative first find, that will decide the order, and power of highest order derivative will just decide the degree, given that your differential equation is a polynomial in derivatives. That's it. Okay, order of the above, yeah, correct. All right. Sine inverse something. In sine inverse, if your dy by dx comes, acha, order directly can you write? Order without even thinking. What is the highest order derivative used? Sir, highest order derivative used is 1. What will be the degree? Sir, dy by dx will be equal to sine of x plus y. Right? Sine inverse theta is equal to something. So theta will be equal to sine of that thing. Right? Simple thing, no? So if you have sine inverse of theta equal to c, then theta is equal to sine c. Simple inverse function we have used, right? So what will be the degree over here? Degree. No matter what x, we are not talking about the polynomial of x and y. We are talking about the polynomial of dy by dx. So in dy by dx, it is a polynomial, right? So degree can be defined. Degree will be 1 only over here. Degree will be equal to 1 and nothing else, right? Keep liking the session if you are coming on the channel. And tomorrow we are going to solve, I'll remind once again, for those who are preparing for 2026 or 2025, tomorrow we are going to solve at 6 p.m. we are going to solve all the questions from 2002 to 2024 of straight lines. Very high weighted chapter, at least 2 questions are expected to come in 2025 also and 2026 also, because the weightage of straight lines has increased due to the removal of tangents and normal parts from mains. So in mains the weightage has increased. Please remind yourself to attend the session tomorrow. It is definitely going to be very productive if you can attend that session. Now, degree and order must be clear to everybody, right? What is degree, what is order? This thing should be clear before jumping into another part. Second is forming of differential equation. How do you form a differential equation? Sir, it won't be given to you. You'll have to form the differential equation. And in mains also, sometimes they have given questions from this category. That what will be the differential equation if this is the condition, or what will be the differential equation for this particular thing. Simple equation in x and y they'll give you, and they'll ask you to form a differential equation out of it. Forming of differential equation. So any equation they'll give you, and how do you think you'll form a differential equation? By differentiating differential equations, by differentiating both the sides. For example, okay, now what do we mean by forming that? What do we mean by formation of differential equation? For example, you have a simple x square plus y square is equal to 4, a simple curve. Or let's take a parabola, y square is equal to 4x. You know, this is the equation of parabola. This is something you have. This is an equation. If we form a differential equation out of it, first of all, what will it mean? Y square is equal to 4x is a parabola, right? Now, a differential equation does not represent just one curve. Write it down somewhere. A differential equation represents, it is important to know this, represents a family of curves. So for this chapter, apart from differentiation and integration, sometimes you might need to know coordinate geometry or conics, basics of conics. If you know, it will be better for this chapter. Okay, a differential equation represents a family of curves. What do we mean by it? For example, if we have a parabola, something like this, and there will be too many parabolas. Why? Because y square is equal to 4x is just one parabola where a is equal to 1. What is the general equation? Y is equal to 4ax. As you change a, there will be many parabolas formed. Now, this is not y square is equal to 4x. Y square is equal to 4x will be like this. Right? There will be many parabolas formed. Many parabolas formed. All passing from origin. Right? This is a equation of, general equation of parabola passing from origin and center at a comma 0. But, focus at a comma 0. But, differential equation, if we form a differential equation out of it, it will represent family of all the parabolas on which every point satisfies the differential equation. Every point on all these parabolas which are represented by this will be satisfying this differential equation. If you find dy by dx anywhere at any point will be satisfying this differential equation which we are going to form. Till now we haven't learned how to form differential equation, but here it is important to understand what do we mean by formation of differential equation. It is important to understand what do we even mean by formation of differential equation. What do we mean? Differential equation represents a family of curve. In this family, every member of this family satisfies the given differential equation. Every member means every point on all the members of this family satisfies the differential equation that we are forming. Are we clear? Any doubt? Anybody? Right? Now here A, what, for example, over here A is nothing but a constant, or we call it an arbitrary constant. We also call it an arbitrary constant. We also call this A as an arbitrary constant. Okay, arbitrary constants means as we change the value of A, different curves will be formed, but of the same family, and when we will convert this into a differential equation, this differential equation will be satisfied by every member, every point on all these curves. That's the application. By this also you can try to understand the application, or why are we learning about differential equations. It is important part of mathematics. All right. Okay. So this is one thing. Let's read the definition also. Consider a family of curves. By forming a differential equation, we mean developing a relation differential equation itself is a relation between x, y and dy by dx. Developing a relation between x, y and a derivative which satisfies or is satisfied by every member of the given family of curves. That's what we mean by it. Okay, that's what we mean by it. Now, how to form a differential equation? It's important to understand how to form a differential equation. Here some things are written. I'll explain you with the examples. We'll come back to that part also, but first let's understand how do we form a differential equation. Very simple step or very simple method is there to form a differential equation. It's not going to trouble you. Arbitrary constant, or you can say arbitrary independent constants. You'll always in an equation, in a normal equation in x and y, in a general equation in x and y, you'll always have some constant involved. Now, differential equation is an equation in x, y and derivative. That means dy by dx. Okay? Or dx by dy can also be there. That we'll discuss it further. But here, simple thing to understand. What should be there in differential equation? X should be there, y should be there, and dy by dx should be there. If t and p are there, then t should be there, p should be there, dp by dt or dt by dp should be there. Okay, x, y and dy by dx should be there. Or if there are two other variables you are taking, independent variables you are taking, then derivative of them should be there. That's simple to understand. Okay. Hi, Hema Prashant. Okay. So here what do we have? Here we have x, y, that we have. We have a and b also, and we don't have dy by dx. So how will we introduce dy by dx? Y is equal to, first of all, write it like this. Y is equal to a sin x plus b cos x. Now remember one simple important step, that you have to derivate it as many times as the number of arbitrary constants. Arbitrary constants meaning we'll keep understanding with the examples. It's just, you have to just derivate your given equation as many times as the number of arbitrary constants involved. Here how many arbitrary constants involved? A and b. We want to remove a and b, right? Because we want x, y and dy by dx. That will be our equation. So we want to remove a and b. If we want to remove a and b, how will we remove? By derivating it. Now dy by dx, first time differentiating. So dy by dx will be a cos x minus b sin x, right? Cos x derivation will be sin x minus b sin x. Differentiated both the sides. Okay, but are a and b removed? No. So, and obviously main step is we have to derivate, or we have to differentiate two times. Why two times? Because there are two arbitrary constants involved. Pay attention at this thing. There are two arbitrary constants involved. That's why we'll have to differentiate it two times. So second time, that means d2y by dx2. Order change. Order became 2. Equal to, now we'll have minus a sin x minus b cos x. That's it. Now how can we remove a and b? Do you see a way of, try to think yourself, do you see a way of removing a and b? Using, let's say this is your 1, this is your 2 and this is your 3. How will you remove a and b? Just give yourself some time to think, how will you remove a and b over here? How will you remove? Anybody in the chat box? How can I remove a and b over here? How do I remove a and b over here? Keep liking the session if you are here, please. And do subscribe the channel if you haven't done that till now. That's our kind request for being motivatedly working. Yes, anything. How will you remove? Obviously, just simply add first and third. Add first and third. If we add first and third, we can get rid of a and b. What? d2y by dx2 plus y. will be equal to a sin x minus a sin x 0, b cos x minus b cos x 0. That means equal to 0. That means what is our equation? d2y by dx2 equal to y, or simply this. Why even writing like this? This is our differential equation. Only y is involved and dy by dx is involved. X, y and dy by dx. Nothing apart from that should be involved in a differential equation. That is our differential equation. Simple. What is the order? Order is 2. What is the degree? Degree is 1. Okay. Order of this differential equation is 2 and degree of this differential equation is 1. Okay. This also keep reminding yourself just for a sake of revision. Nothing much. Alright. Now see, how many arbitrary constants do you see? Sir, only one. Only c is there, because apart from x and y, what is there? Constant, arbitrary constant is c. So how many times we'll have to differentiate? Once, right? So first let's write this y is equal to c x minus c whole square dy by dx. Once we are derivating, once we are differentiating, right? Once we are differentiating, so dy by dx, here it will become 2c x minus c, and then multiplying with derivative of x minus c, which is 1 only, which will be 1 only. Okay, not a problem. Two equations are formed. Now think how can you remove c? Think yourself, how can you remove c? Anybody in the chat box? Think yourself, how can we remove c? How do we remove c? Just by dividing, right? Best way to remove c is dividing. C will get cancelled, right? Removing c. So if I divide y upon, let's say this is dy by dx means y dash, or if you want to write dy by dx, you can write that way also. C into x minus c whole square divided by 2c into x minus c. So this will cancel it 1 times and c will get cancelled. So what do we have basically? We have y by y dash equal to, see, c is still there in x minus c, but that doesn't mean we have to derivate it once again, or we have to differentiate it once again, right? One arbitrary constant, just mark this in your heads, in your brains, that if there is only one arbitrary constant, that means we have to just differentiate once only. Two arbitrary constants, differentiated 2. One twist comes in this story also, but that I'll tell you how it comes. But the main concept of forming a differential equation is this only: number of arbitrary independent constants and derivated that many times, differentiated that many times. All right, y by y dash. Now how to get rid of c? We still have c, na? X minus c upon 2. This is what we have. This is what we have. How will we get rid of it? C ka value we can find, no? C ka value is, what is the value of c? 2y by y dash minus x. C will go this side, no? So 2y or x minus 2y by y dash, correct? 2y by y dash, c will come this side, this will be x minus 2y by y dash. C's value we have. This value of c, we'll put it in any of the equations, whichever you want. This is your first and this is your second. Two equations will be formed. If there are 2 arbitrary constants, 3 equations will be formed. If there is 1 arbitrary constant, 2 equations will be formed. If there are 4 arbitrary constants, 5 equations will be formed. That's it. So you can use anyhow you want. C we have. So this will become y equal to x minus 2y. C value in 1 I am putting. X minus 2y by y dash multiplied with x minus c. That means x minus 2y by y dash. That's c whole square. That's it. This is your differential equation. What do we have now? X, y and dy by dx. Y dash means dy by dx. X, y and derivative. Only these things we have. So that we have formed our differential equation. We have formed our differential equation. This is our differential equation. Differential equation means simply just remember x, y and derivative. Nothing apart from that. When you achieve that, that means you have achieved your differential equation. That's it. Nothing, not a problem at all other than that. All right. Yeah, same thing only, right? Okay, if you solve it further, right, you can solve it further also, no? X y dash minus x minus 2y whole square, this complete thing whole square, if you solve it further, it will come something like this, y dash cube, something like this. Or you could also put value of c over here also. So this will become y dash equal to 2 times of x minus 2y by y dash into x minus 2y by y dash. C ka value, just put c ka value over here, and both the equations, anyhow you form, in both the ways you'll get the same differential equation, not to worry about that. Now sometimes statements will be given to you, not directly, they'll not give you an equation in xy and ask you to form a differential equation. Sometimes they'll give you conditions or statements, right? You should be able to understand that as well. For example, family of parabolas having vertex at origin and axis along positive y-axis. They are talking about all these parabolas. Family, see, differential equation means family of curves. It's not about a particular curve. Family of curves. So this is your family, like all the parabolas whose axis is along y-axis. So that means x square equal to 4ay. This is your general equation of parabola whose axis is along y-axis. X square is equal to 4ay is the general equation. This you have to convert into differential equation. Now this is your equation in xy, condition for parabola having axis along y-axis. Now when you'll form the differential equation means entire family of these type of curves where every point, every member satisfies that differential equation. Okay, here problem is a, this is an equation in x and y and a, arbitrary constant means a, only one arbitrary constant. Okay, 2x dy by 2x, okay, not dy by dx, this side dy by dx won't come, is equal to 4a dy by dx, or I shall write y dash. Dy by dx means y dash, right? If you are in class 12th and if you have learned about derivatives a little bit, you'll understand y dash means dy by dx only. Okay, this is how you'll differentiate both the sides. This is how you can differentiate both the sides. How many arbitrary constants are? One arbitrary constant. That means this is our first equation, this is our second equation. We have to get rid of a now. What is a? From this we can say a is nothing but 2 times cancelled. Okay, so x upon 2 y dash. This will again put in the first equation, and what do we get? X square is equal to 4 times of x upon 2 y dash into y. Okay, x and x is also getting cancelled. So what do we have? This gives us x, this gives us 2xy dash equal to 4 times of y. That's it, equal to 4 times of y. Correct only, no? 2xy dash equal to 4 times of y or 2 times of y. Acha, 2 times of y. This 2 and this 2 will also get cancelled. No? 2 here we cancel here. How? Acha, here also one more 4 is there. So 4, correct, not a problem. This 2 will also get cancelled 2 times. So xy dash equal to 2y is our differential equation. Only x, y and y dash is involved. Sometimes you can also do this directly removing the arbitrary constant. So if you keep the constant on one side and bring everything else on this other side, that also can give you your differential equation quickly. It is lagging. The video is lagging. Let me see. Get more and more of you guys' attention. Is it still lagging? Samath, thank you. Okay. Just a minute, guys. सर आप हो गए हैं? ये लाग हो रहा है बहुत गंदा. ठीक है, एक सेकेंड. ठीक है. Okay, so sorry for the issue. Thank you, Bharat and Protractive, for letting me know. Sometimes due to technical things, which we generally do understand the technical things, but sometimes things comes out of syllabus for us. So that's why I had to call for help. I hope the session will not get delayed because of this. Let's come back to what we were doing, to what we were going through. Okay. Yeah. Generally, you know, now we guys are pro enough to handle the issues on our own, but you know, sometimes things come totally out of the box. That's when we fail. Okay, so we did this, right? We did this. We have I'll repeat it. I'll just revise. Family of parabolas having vertex at origin and axis along positive y-axis. So general equation of parabola for axis along y-axis or the family will be represented by x square is equal to 4ay. Here arbitrary constant was 1 only. Only a was the constant. So what did we do? We just differentiated once. Number of arbitrary constants will tell us how many times do you need to differentiate to form a differential equation. That's why we differentiated just once. Okay, that was the idea. Now after that, what did we do? We removed a. So from here we found the now we can just use these two equations to remove a. Our objective is to remove a. We found the value of a from here, which came out to be this, and we put this value in the main equation, first one only, or you can put this in second one also, not a problem. And that's how we get, finally we get our differential equation as this: xy dash is equal to 2y. Now what I was saying, I was saying that sometimes when you have such type of equations and you have to convert it into differential equation, what you need to do is try taking all the constant on the one side, entire constant thing on the one side and variables on the other side, and then do the differentiation. That is also one faster approach for doing this. For example, here what we could do is x square by y equal to 4a. Right, x square y equal to 4a, and then differentiate it. So differentiating on the left side, right, u by v form, this is u by v form, correct. Right side, what will happen with this right side differentiation, if you will do, it's a constant, differentiation will become 0. Here what will it become? Y square u by v form, so y square y into 2x minus y into derivative of this minus this into derivative of y, which will be y dash, correct. this is what you're going to get, equal to 0. Equal to 0. So this entire thing will go that side and become 0. We'll have 2xy equal to x square y dash. Do we have the same thing? Here we had 2xy. Kya? Acha, x and x are getting cancelled here also. 2y equal to xy dash. Same equation we are getting. Same equation we are getting. Correct? So, but this is a faster approach. Suppose you want to obtain the differential equation and such kind of scenario is there that you can shift the entire constant on one side, then use that approach, faster one, and then differentiate it on both the sides. Please, if you are there on this channel, do not forget to like the video, like the session. This add credit, this doesn't add credits to our work, but you know, this helps the channel to grow faster and help us to work in a better way. So that's why I'll keep asking you guys to, you know, do not forget to hit the like button. Like button is there in front of you, but I don't know why you guys forget to hit it sometimes. You might have your own reasons, but I'll remind you. Okay. Now, family of hyperbolas. Let's do it here also. Acha, here. Look here. Here constant is on the right side. Kya? Only there. Is there only one constant? There is only one constant, A. It's not on the, it's not, I'm not talking about constants like 1 and 1. We don't need to worry about it. Main is arbitrary constant, which is this A square. We have to either, if we can shift it on the same, on single side, right or left, that's good. Otherwise, we'll just differentiate the entire equation just one time, because only one arbitrary constant is there. Do you agree with me? Do we need to differentiate it more than one time? Do we need to differentiate it more than one time? No, sir. X square by A square minus Y square by 1 equal to 1. Differentiate it once. So this will become 2x by A square. Okay, 1 by A square will come this side only. This will become 2x by A square, or you can do one thing also. You can do this, x square by A square equal to 1 plus Y square by 1. Here 1 plus y square only. No, why are we even writing this thing? Now I was talking about shifting the constant on one side. Here, do you see you can do it? Yes, we can do it. This will become 1 by A square equal to 1 plus y square by x square. You have shifted your constant on the one side. Now when you differentiate on both the sides, it will be much simpler. Again, u by v form. So x square whole square. So x square, x to the power 4. Oh, did we do something wrong? 1 by y square by x square, a square. Okay, it's better that we write it this way only. So a square will become x square upon 1 plus y square. Although you could do that way also, 1 by square a square still remains the constant only, right? But just writing it in this form. Now this side will become 0. Right side, what are we going to have? Right side, u by v form again, 1 by y square whole square. This thing as it is into differentiation of this 2x minus x square as it is, and derivative of this, which will be 1 plus 2y y dash. 1 plus, 0 plus 2y y dash. So 2y y dash I'm just going to write. Okay. X square into 2y y dash. Differentiation and integration both are supposed and required to be in a good grip for this chapter. Both of them. Right now we are just using differentiation. As we move ahead in the chapter, we'll be using integration also. But don't worry about it. As much as I can tell or make you revise, I'll revise. Okay, so this is u by v form, quotient form. That's what we have used over here. Now this thing moving there will become just 0. X square, 2x square y y dash will be equal to 2x 1 plus y square. X will cancel this, 2 will cancel this. X y y dash equal to 1 plus y square. That's it. Or you can also write it like this, y dash equal to 1 plus y square divided by xy. This is your differential equation, final differential equation that you need. Only x, y and derivative of y is involved over here, nothing else. Okay. All right. Let's see some more. Statement wise. statement wise it is written like this: all concentric ellipses with principal axis along the coordinate axis. All concentric ellipses with principal axis along the coordinate axis, basically they are just talking about these ellipses, right? They're just talking about these ellipses. So now what is the general equation? We'll just write the general equation: x square by a square plus y square by b square equal to 1, right? Equal to 1. This is our general form. How many arbitrary constants do we have? 2 arbitrary constants do we have. Can we shift them on the one side? I don't think so. Can we? No, I don't think so. So we'll have to derivate it. We'll have to differentiate it in this form only. We'll have to differentiate it in this form only. So this will be 1 by a square 2x plus 2y y dash upon b square equal to 0. That's one differentiation. One more time we'll have to do. One more time. Hi Govind, how are you? All good, having fun? One more time we'll have to do, because 2 arbitrary constants, right? This will be, let's say this is our equation 1, this is our equation 2. We'll need one more equation. Just remember, for forming the differential equation you have to derivate it or differentiate it as many times as the number of arbitrary constants that you have. Some exceptions are there that I'll explain you in the further questions, but for now this is the thing. Acha, can we get rid of a and b somehow? Here we are able to shift constants on the one side. So can I write it like this: b square by a square is equal to 2y y dash divided by 2x. 2 again got cancelled. Minus also will come, na? Minus also will come, right? So this is your second equation. Till now also you have second equation. You'll have to differentiate it one more time. So just asking you, reply in the chat box, can we say that number of arbitrary constants in an equation also decide the order of differential equation formed out of that equation? Can we say that? Tell me. Yes or no? Can we say that? Yes, we can say that, obviously. Right? We can say that. Now this will become, again we'll differentiate. Again we'll differentiate. So now 2 got cancelled. Right side will become 0. This will become 0. Differentiation of constant will become 0. This will become what? Will be equal to x square. Here we are going to have, it's stucking on my is the video still stucking, like lagging? On my screen it is showing. Please confirm once if you can. Otherwise we get to know after so much time. That's bad. Okay, so x square will come over here. Now x into y double dash, y dash y double dash, right? This only will become, keep checking, or no, not y dash y double dash, it will become y dash into y dash. That means y dash square. Y dash square, can I say? Minus y into, sorry, y dash into derivative of x. That means y double dash over here. Y into y double dash. Y into y double dash. I've written this one first. Because there is a negative sign, no? I'll explain once again. Although this you should be able to do. X square will come here. X into y dash. X as it is. Y dash derivative will become, y dash derivative will become y d2y by dx2, right? Y double dash it will become y into y double dash, it will become x into y double dash, it will become minus y dash as it is into derivative of x. But here we have already a minus, so I am writing in the other order. Minus is getting cancelled. I hope you are getting my point, right? So it will become y dash whole square plus y into y double dash. It will become y dash whole square plus y into y double dash. This is how it is going to become, this entire bracket. Minus one derivative is still there, y dash minus y dash. This thing will come, x square will be over here, right? Just check once. Do you agree? By y dash will be y into y double dash plus y dash into y dash. That means y dash square. Y into y double dash plus y dash square. Product rule will happen here. For derivative of this y dash, derivative will be y into y double dash plus y dash into y dash. That means y dash square. Correct? This is that part. And x will be multiplied minus derivative of this. That means y dash only. That means y dash into derivative of this. Same thing. Derivative of x will be 1 only, so minus y dash. This will be your entire thing. And now you can say y dash equal to x y dash square plus y double dash. What is the order of the derivative over here? If I ask you, can somebody tell me what is the order of this differential equation? This is your differential equation final. What is the order here? What is the highest order derivative? Double dash. 2 is the order. What is the degree? Power of the highest order derivative. That means power of y double dash, which is 1. Order will be 2, degree will be 1. Am I correct or not? Let me know. Am I correct or not? Degree will be 1, order will be 2. Here, differentiating over here is a little bit trickier for you. Not tricky also, like if you can simply apply the quotient rule and product rule, you can easily do that. See, quotient rule I have applied, u by b. So v square, v into u dash minus u into v dash. Okay. Now see, in v we have y dash. Here 2 terms are there, product rule will be applied. So y into derivative of this, that means y double dash. This is that. Then y dash into derivative of y, that means y dash into y dash. So y dash square. Whole multiplied with x, u into v dash. V dash will be this entire term, right? Minus v into u dash. That means this into this. Sorry, this into derivative of x. That means y dash into derivative of x, which is 1 only. So minus y dash. That's it. That's it. That thing only I have done. I hope you can understand it, right? Differentiation also, as much as I can explain, I'll keep explaining you. Now, general differential equation of the family of circles. See, from the first part only, from the very first things which we have learned so far, questions will come. But as I told you in the starting also, family of curves you'll have to remember. Not family of curves, basically coordinate geometry and basic knowledge of conics should be there. If the question comes in mains or advanced from the initial part of differential equation. From the initial part, if they are making the question, no, they'll try to involve conics over there. Because what does a differential equation mean or represent? Differential equation just represents a family of curves, as we read in the starting definition. Keep liking the video if you are there on the channel. Keep liking the session, I mean, if you are there on the channel. And if you have not subscribed, subscribe it. We are doing the regular sessions on PYQs from 2002 to 2024. 2 sessions are done from chemistry and physics. Tomorrow we'll be solving all the PYQs of straight lines. So if you are struggling with straight lines, or if you want to master straight lines, which is a very high weighted chapter, at least 2 questions are expected in 25 also and definitely in 26, then do attend that session. It will give you a good grip over straight lines. All right. Now, differential equation of family of circles passing through 0, 2 and 0, minus 2. 2 points are there and it is asking about the family of circles passing through these 2 points. Many circles will pass through these 2 points, right? Many circles will pass through these 2 points. There will be many circles, correct? There'll be many other circles. One circle will be here. I'm not forming just to avoid the gitch pitch, but many circles will be there. Now here the knowledge you require is how do we write the family of circles which passes through 2 points. Okay, how do we write the family of circles which passes through 2 points? So make a remark, family of circles passing through, I'm just revising this part, through x1 comma y1 and x2 comma y2, 2 points, right? These two are points. Let's say this is x1 comma y1 and this is x2 comma y2, right? So first write the, first assume it as a diameter and write the equation of circle in the diameter form. That means x minus x1 multiplied with x minus x2 plus y minus y1 multiplied with y minus y2. This is the diameter form, right? Where the endpoints of diameter coordinates are these. This is the diameter form plus the equation of this line into lambda. Lambda into equation of this line. That's it. This line segment. Equation of line. This is your line. Okay, equation of this line. For example, over here, if we talk about this line, equation of this line, a line passing from 0, 2 and 0, minus 2. Y-axis only. This is y-axis only. X is 0. That means y-axis only. This is nothing but a y-axis. Line is nothing but y-axis. Diametric form, x minus 0 into y minus 0. Oh, sorry, not x minus 0 into y minus 0, x minus 0 into x minus 0. X minus x1 into x minus x2 plus y minus y1 into y minus y2. Correct? Plus lambda times of equation of this line. That means, what is the equation of y-axis? X equal to 0. Lambda times x. X equal to 0, obviously you cannot write. Just ax plus by plus c wala part. Only that much you have to write. So lambda x. Correct? This is your family of circles which are passing from 0, 2 and 0, minus 2. Rest is nothing but this will come x square plus y square minus 4 plus lambda times x equal to 0. Only one arbitrary constant is there, lambda. So you have to differentiate it just one time. So what you can do, you can just simply do by x, by x and shift this lambda on the right side equal to minus lambda and then differentiate it on both sides. You will get your equation. You just need to do this much. Differentiate it on both the sides. Directly you will get your differential equation without doing anything, without falling into much trouble. Getting my point? So here main concept which was required was, concept of forming the differential equation was not that much. Concept was of circles. Okay, family of circles basically. Okay, family of straight lines and family of circles directly they won't ask in mains, but yeah, they'll involve it somewhere in the questions. Family of circles is there in main syllabus also. Family of straight lines is not there in main syllabus from 2023. It's a 2022 question, so that time these things were there, but now many parts of circles are removed. Many parts of tangent, normals and those parts are removed. Straight line has become more of the weightage, so that's why. Okay, that's why I'm saying try to attend tomorrow's session if you can. That will be definitely helpful for all of you. Rest we can do, right? Differentiating x square plus y square minus 4, x square plus y square minus 4 divided by x is equal to minus lambda. Right side will become 0. Not a problem at all. Left side, what will left side become? X square, differentiation. Again quotient rule. So x into 2x plus 2y y dash. That's it. So x into u by v, v square in the denominator, v into derivative of x, v into u dash. So derivative of this will become 2y plus 2x plus 2y y dash. Right? Differentiating with respect to x. Minus 4 will become 0. Minus this entire thing into derivative of this. So that means x square plus y square minus 4 equal to 0. That's it. Equal to 0. Anything else? X square into 1 only, no? So into 1 we don't need to do. Into derivative of x will be 1 only. So that's it. So we have 2x square. This will open 2x square plus 2xy y dash equal to x square plus y square minus 4. Correct? That's your differential equation. If you want, in options, if they've given you in this form, the y dash is equal to x square plus y square minus 4 upon 2x square plus 2xy. Let's see. Do we have options? This only is given. 2xy y dash plus x square plus y square plus 4. X square plus y square minus 4. This only is given, no? Same thing. This only is given. 2x square minus x square will become x square, right? So it is nothing but x square minus y square and 2xy dy by y dash I'm writing as dy by dx. Okay, y dash I'm writing as dy by dx. So 2xy, I'm just trying to show you in the option form. dy by dx, 2x square minus x square minus y square plus 4 equal to 0. This is given to you. Correct? Which option is this? This is option A. Right? That's what we have. Okay. Please, if you are there on this channel, do not forget to like the session and subscribe the channel. Also, if any of you know anybody preparing for 2026 or even 2025, ask them, recommend them to subscribe the channel, as we have started new series for 2026 where we are solving all the PYQs from 2002 to 2024. Reason is that 5 years PYQs are not enough to crack JEE or even mains. They are not enough. Strategic development is very important over here, so do not forget. Now, okay, sometimes question can come like this also, right? They'll give you an equation, they'll not ask you to form the differential equation. They'll ask you what will be the order of differential equation formed out of these equations. Differential equation of the following. Now, we have learned that number of arbitrary constants will decide how many times do we need to differentiate. The number of times we differentiate, that will decide the order of your differential equation. That's simple to understand. Correct? But here in these type of questions, there's a catch. The catch is written over here also. The order of difference, read it very carefully. You have to remember this. Or in this type of question, definitely you will make the mistake, because generally student thinks number of constants, number of arbitrary constants, that will decide the differential degree, that will decide the order of differential equation. But that here also there is a small catch. What is the catch? Let's understand. The order of differential equation of a given relation is equal to the number of independent arbitrary constants. Not just arbitrary constants, independent. For example, if I write something like this, y is equal to a cos x. Okay, wait. Y is equal to b cos x plus a cos x. Now, how many times do you, to form the differential equation, how many times do you think you need to differentiate? 2 times, because a and b are involved. No. 1 time only, no, because b plus a will come out as common and cos x will remain here. Now, b plus a is dependent or independent? These are dependent. A plus b, a and b both are dependent because they can be taken common out. So, 1 time only you have to differentiate, because a plus b will form a constant which will be single. A plus b will be clubbed up and it will form just one arbitrary constant. Same thing is happening in these questions. Same thing is happening in these questions. Look, here C1 and C2 cannot be clubbed up. Can we club them up? Can we club them up? Anyhow, no, we cannot club them up. If it was ln or log or something, then we could think, but here we cannot club them up. So here simple, two arbitrary constants are there, two independent arbitrary constants are there. So order will definitely be equal to 2, because we'll have to differentiate it 2 times to form the differential equation. So order is definitely going to become 2. Automatically it will become 2. Here C1 and C2, can I write it as D1? C1 and C2 club together, C1, C2, C3, C4. Sir, there are 4 arbitrary constants. Yes, there are 4 arbitrary constants. But how many independent arbitrary constants? These two will club up and form just one constant. Right? These two will club up and form just one arbitrary constant. That is D1. Let's say. Here also there is something. Here C3 is there. Here C4 is there. C3 multiplied with e to the power x plus C4, won't this form a single constant? No, not like that. Wait, not like that. Let me write it like this. C3 into e to the power x into e to the power C4. Can I write it like this? This thing. I can write it like this. No, e to the power x into e to the power C4. That only means e to the power x plus C4. Correct. So now C3 into e to the power C4. This is a constant. Let me name it as D2. So what did the entire thing become? D1 plus D1. Wait. D1 e to the power x plus D2 into e to the power x. D2 into the e to the power x. D2 into e to the power x. How many arbitrary constants are now are there? 2. D1 and D2. No, these also can be clubbed up. I can take e to the power x as common, and D1 plus D2 will form another arbitrary constant which can be written as e to the power x into e, or f I should use. Only one. So order over here for this one, order will be equal to 1. Why? Because finally independent arbitrary constant is just 1. Very small thing but very important thing. Direct question if comes like this, no, don't just look at the arbitrary number of arbitrary constants and mark your answer that order will be equal to 4. This can come in objective, right? In mains also it can come. I couldn't find, but yeah, there are questions like this where they're just asking you order of difference. If they want to ask you questions about order and degree, no, they'll ask you these type of tricky questions. So pay attention here. Here number of arbitrary constants are 4. But independent are just coming out to be 1. Why? Because all the arbitrary constants can be clubbed up and formed as 1. Okay, C1 plus C2 will form one constant. C3 into e to the power C4 will form one constant. Finally, e to the power x, if we take common, then D1 plus D2 is also forming just one constant. So that's why. Okay, did we understand? Please let me know in the chat box. Now we are moving towards the main part. Formation of differential equation we have understood. Now what is required in this chapter, why this chapter is taught or why this chapter is included, is for this reason: to be able to find the solution of differential equation. In order to find the solution of differential equation. Just a minute. Studio. Just a minute, guys, let me check if everything is fine. Voice and video is fine. Can somebody reply? Can somebody please reply that whether the voice and video are working fine? Mm. Wait a second. Okay, I'll see on my phone. Why is it running so late? Okay, great. All right, so let's move ahead. Now the main part. See, if you are watching it in recording later also, no, try to solve each and everything. Or if you are learning this chapter for the first time and you are a 2025 aspirant, I would recommend solve this chapter along with me. You can make sure of getting one correct answer from differential equations, which is a definite question. One question definitely is going to be there. Array, that screen, where did you go, man? Okay, no problem. Leave it. I'll see later. One question you can definitely mark for yourself. That's what I was saying. Solution of differential equation. What did we learn? What did we learn till now? We learned formation of differential equation. That means there'll be a family of curves, right? And no, sorry, let me write it like this. That means there was one equation given to you. There was one equation in x and y was given to you. Okay, one general equation was given to you. You differentiate it and you formed a family of curves. Till now we have learned that only, right? What did we mean by making a differential equation, right? Basically, what did we do? We had a family of curves. Y square is equal to 4ax, or x square by a square plus y square by b square equal to 1 was given to us, and that we converted into a family of curves. Family of curves means now every point on this family, every point or every member of this family will satisfy the differential equation which we have formed. That was the meaning of it. Mathematical meaning of it was that. That means when we had a family of curve, right? For example, anything you can take. We had so many. Y square is equal to 4x. We had that was representing a family of curve. From that, right? From that to form a differential equation, what did we do? We differentiated. Right? When we differentiated a family of curves, what did we get? A differential equation. Right? Now, if we have a differential equation, what will be its solution, do you think? What will be the solution of it? What do you think of it when we talk about the solution of differential equation? Right? If we are saying that I want a solution of differential equation, obviously by meaning solution means it's not a value. In solution of linear equation or quadratic equation, we'll get a value, right? Roots or solution, something like that. Here it is important to understand what do we mean by solution of differential equation. I can say that when we differentiate a family of curves, we get a differential equation. Correct? When we differentiate a family of curves, we get a differential equation. Now, if we have a differential equation, what will be its solution? Its solution will be again family of curves. Right? Suppose we have some differential equation, we solve it, and finally we get y square is equal to 4ax. That y square equal to 4ax will be its solution. That will be its solution. Their derivative will not be involved. So solution means again coming back to that family of curves, and from here to here we reached by differentiating. So from here to here back again we'll go by integration. That's why I said in the starting that both integration and differentiation are involved heavily in this chapter. So if you think you need to revise that, please do revise that part if required. Now, okay, understood? Family of curves gave us differential equation. Solution of differential equation will be again back that family of curve only, and that will be reached by integration. Let's see how. The solution of a differential equation is a relation between dependent and independent variables only, free from derivatives. Now, in the solution of a differential equation, there won't be any derivative. Y square equal to 4ax. This is the solution of some differential equation. Which differential equation? Which we formed while by derivating it, while differentiating it one time. Correct? Solution means coming back to this form, free from derivatives. Only dependent and independent variables are there. Dependent variables are x and y, independent variable is a. Correct? So such that it satisfies given differential equation. It is important to connect between two things: formation of differential equation and solution of differential equation. If you can understand this, then it will be easier for you to even understand the rest of the part. Right? That also won't bother you. Okay. The solution, now two types of solutions are there. Integration is involved. Integration is involved. Integration is involved means we don't have definite integration over here. Indefinite integration will be there. Right? There won't be any limits. Indefinite integration is there. That means there will be some constant which will come. Plus c, minus c. Right? Some constant will come along with integration. Now, there is some theory written over here, but in simple words, I'm saying General solution means with that constant. General solution of a differential equation means constant of integration will be involved. Particular solution means if we are able to find the value of constant and or the value of constant is known to us, then that will be particular solution. General solution means entire family of curves, right? Entire family of curve. Particular solution means from that family one particular member. By this parabola only I want where a is this or something like that, right? If I want y square is equal to 8x, this is a particular solution of your differential equation. But y square is equal to 4ax, where a is some independent variable, that means this is general solution. If we are able to find the value of a, it will make it a particular solution. General solution means representing entire family of curves. Particular solution means a member of that family of curve. This is how we can portray it or understand it. All right. So let's read this also. A solution of differential equation involving exactly the same number of arbitrary constants as is the order of differential equation. Obviously, if differential equation order is 2, that means 2 arbitrary constants are involved. That means it's a general solution. A solution obtained by assigning values to the arbitrary constant, if we are able to find the values of arbitrary constants, that will form a particular solution. Right? In general solution only, if we are able to find the value of arbitrary constant, that will form a particular solution. Now, solution of differential equation. Now we'll jump towards the main part of this topic, solution of differential equations. Okay, generally there are some forms. The good part is that there are specified formats for finding the solution of differential equation, right? What are those formats? Variable separable form. Variable separable, where we are able to separate, we'll understand with the examples, but right now just the names of it. Reducible to variable separable form. Some of the equations can be reduced to variable separable form. Then there'll be linear and homogeneous. Homogeneous and linear. Homogeneous also mainly means this part only. Homogeneous differential equations are involved in reducible to variable separable forms. I'll explain you while we move ahead in the chapter. Linear differential equations and equations which can be reduced to linear differential equations, and some are in the exact form. You have to use that exact form to find the solution. These are the formats which we are going to talk about and study about. Now, first, variable separation form. Variable separation form means if you are able to keep y variable, right, function of y with dy and function of x with dx, then this will be called as the variable separable form. That means entire function of x, all the terms involving x are with dx, all the terms involving y are with dy. That means variable separable form is achieved. Let's understand with the examples. For example, over here, f of x dx plus g of y dy. Okay, f of y we have involved, different functions will be there, so g of y should be named it as. For example, a, this one, 1 plus x into 1 plus y is written, right? You should actually remember this also. Whenever you have x, y and xy, right, or x square, y square, x square, y square and 1, right, 1 x, y and xy, or 1 x square, y square and xy square, terms like this, they can be obtained only by this, no? 1 into 1, 1 into x, 1 into y and x into y. That means factors of these will be dy by dx equal to 1 plus x into 1 plus y. Now here, can we separate the variables? Yes, we can keep 1 by 1 plus y with dy. So we can write like this, dy upon 1 plus y equal to 1 plus x into dx. Now all the terms involving x are with dx, all the terms involving y are with y. Now for finding the solution, integration. Integration means integrating on both the sides. It just means integrating on both the sides. Right? For finding the solution, we just need to integrate over both the sides and nothing else. And now integration, this is standard integration, right? 1 by x, but x is in linear form, so it will become ln of 1 plus y divided by coefficient of y, which is 1 only. So ln of 1 plus y. And right side, x 1 will become x, integration of x will become x square by 2. Correct? And constant of integration, which is c. Now here there is nothing given to us for finding a particular solution, so this will be called as your general solution. Now there is no derivative involved. To remove the derivatives, integration has come into picture. How will we remove the derivatives? By integration only. Integration only can remove the derivatives. So this is an equation which does not involve derivatives, only involves independent and dependent variables. X and y are dependent variables, c is an independent variable. That simple of it. Okay. So this is your solution of differential equation. This will be called as your solution of differential equation and nothing else. Okay, understand. Variable separable form, that means we could separate the variables. Y function we could keep with dy and x function we could keep with dx. That's why we can form it is in variable separable form. Now over here, can we do that? Can we do it over here? Log of dy by dx. Log of dy by dx, base will be e. So can I write like this? Dy by dx equal to e to the power 3x plus 4y. This I can do na, to remove the log. First of all, first thought which should come in my mind. Acha, here look, here something is given to find the particular solution also. Okay, we'll see what can we do about it. If it is given, then only we'll find the particular solution, otherwise we'll not. Right? Just for the knowledge sake, right now listen to me. Acha, can we separate the variables? Yes, we can. Dy by dx will be equal to e to the power 3x into e to the power 4y. Correct? Now e to the power 3x will put with dx and e to the power 4y will bring with dy. So dy by e to the power 4y equal to e to the power 3x dx. And now we'll differentiate on both the sides. This will become e to the power minus 4y upon minus 4. So pi 4 equal to e to the power 3x upon 3 integration only plus c. Plus c will be there. Correct? Now what to do about this? Think about it. What to do about this? Just a minute. What to do about this thing which is given? y0 at x equal to 0. y0 at x equal to 0 means 0 comma 0 is a solution. This just means 0 comma 0 is solution of my differential. No, not solution. Sorry. Writing this will be correct, wrong. 0 comma 0 satisfies. 0 comma 0 here. 0 comma 0 cannot be a solution of differential equation. We can say 0 comma 0 satisfies differential equation. This is our differential equation. This is our differential equation. There is no derivative involved now. But c we can find. We can find c. That's why these values are given to us. 0 comma 0 e to the power 4 into 0, that means minus 1 by 4 equal to e to the power 0 upon 3, that means 1 by 3. So 1 by 3 plus c. That means your c will become 1 by 4 plus c will become 1 by minus 1 by 4 minus 1 by 3. So minus 3 minus 4 minus 7 upon 12. C will be equal to minus 7 upon 12. We could find the value of arbitrary constant over here, or we could find the value of independent variable, which is c. Arbitrary constant, calling it arbitrary constant will be more suitable. Okay, please keep liking the session and subscribe the channel if you are there on the channel. Liking the session matters to us. C equal to minus 7 by 12. We'll put it over here. So that means what is our solution? E to the power 3x by 3 plus e to the power 4y by 4 equal to 7 by 12. This will be our differential equation. Solution of differential equation will not give us differential equation. This is our solution of differential equation because this does not involve any derivatives. Correct? This will be our answer. Huh? Something wrong we did, kya? This thing only, no? This thing only, kya galat? What did we do wrong, man? Okay. Sahi. Acha, reciprocal they have done. Okay. They have taken the LCM and done the reciprocal. Okay, not a problem. Only that you can do on your own. Find the general solution of the following differential equation. This is a differential equation. It involves derivatives. Okay. What is our approach? First, we'll look for, right now we are studying about variable separable form. So we'll try to separate the variables. How will we separate the variables? Can we bring y with y dash and x with x separately? Right? What is this actually? 2x dy by dx. Y dash means dy by dx equal to 3y. Sir, we can do one thing. What we can do is, sir, we can do dy by 3y, okay, is equal to dx by 2x. Variables are separated. Integrate on both the sides. Correct? Variables are separated. This will become 1 by 3 ln y equal to 1 by 2 ln x plus constant c. Correct or not? Correct? 1 by 3 minus nahi. Okay, this will become, now see, whenever your solution, this is recommended. Why? Because when you'll see options of the solution of this differential equation, in options if this comes, options will not involve c directly. Okay, options will not involve your c directly. It will be given in some other form. So whenever you see ln or log in the solution of your differential equation, what you do, try to write the if I write c or ln c, will it matter? Ln c is also a constant, right? Will it matter if I write c or ln c? No. Here, if I write it like this, ln of y to the power 1 by 3 equal to ln of x to the power 1 by 2, it won't also matter. Ln c. What will change? Ln will get cancelled. That is why write your constant with ln. Whenever you see in the solution, if you see constant without ln and everything else is with ln or log, write constant also in the form of log. Now what will this become? This will become ln of y to the power 1 by 3 minus ln of x to the power 1 by 3. Right? Ln of y to the power 1 by 3 minus ln of x to the power 1 by 3 equal to ln of c. Here also we can solve. Ln x minus ln y means ln x by y. So this will become ln of mod. Mod is definitely going to be there, but here no information is given. Okay, y to the power 1 by 3 divided by x to the power 1 by 3. Okay, this is ln mod y. This is ln mod x. Okay, do not forget to put, although it's okay. Here there is no information given about it, but we are assuming that they are positive. Okay, and anyway, y to the power 1 by 3, this will become, this will open with positive only. This will open with a positive sign only. But still, whenever you deal with ln or 1 by y or 1 by x integral, then remember mod also. I'll keep explaining you the importance of this mod in the further questions. Here I also forgot, but okay. This will be like this, equal to ln of c. Now ln gets cancelled, so your y by x to the power 1 by 3 equal to c. This is your final solution. In the solution, this might be given to you in the options. In the solution, it's not necessary that they'll involve ln. Okay. All right. Okay. This is how they'll give you. Let's come to the next question. See. Hey, something wrong. We did kya again? Nahi. No. C x to the power 3 by 2. It's one. No, they sent x over there. A 1 by 2 it is. X to the power 1 by 2 it is. Oh, x to the power 1 by 2 है. 1 by 2 है. So y to the power 1 by 3 upon x to the power 1 by 2 equal to c. Correct. So this will become y to the power 1 by 3 equal to c x to the power 1 by 2. Right? 1 by 3 will go that side and will become 3. So y will be that side, it will become power 3. So cx to the power 1 by 2 to the power 1 by 3. That means it will become cx to the power 3 by 2. That's all. Okay. Now 2022. Let's solve a PYQ. Give it a try. Give it a try for a minute. Try to think. Can you bring it into variable separable form? Are the variables can the variables be separated over here? In mains, you know, they'll always give you this condition. Here they didn't give. This was not a PYQ. Otherwise, here also it should be mentioned that x and y are greater than 0. Then only we can move ahead of this step. Otherwise, this y will open with a negative sign. If x and y are less than 0, then this mod will open with a negative sign. No, that's why I was saying mod, you remember. Because in PYQs, if you'll see, they'll always give you the condition for x and y. Because ln, if they think ln is involved, then mod will be involved. That's why. Okay. Keep liking the session, guys. Do like the session if you are here. And do subscribe also, so that you keep getting the notifications for whatever we are doing. Please do not forget to like and subscribe. I keep reminding this, but still I see a lot of them who don't pay attention. All right, what do you think? Can we do something about it? Can we separate? It's quite visible only, na? Quite visible only. See, dy by dx plus 2 to the power x minus y. That means 2 to the power x upon 2 to the power y multiplied with 2 to the power y minus 1. 2 to the power y minus 1 over here divided by 2 to the power x minus 1. Correct? Now variable separable form is achievable. Do you think so? Now we can achieve the variable separable form. Yes or no? Keep writing in the chat box. Everybody says that English channel students, if they come also, they don't reply in the chat box. I don't know why. Okay. Now can we do something about it? Equal to 0. Equal to 0. Equal to 0. So, So 2y like this. 2 to the power y dy divided by 2 to the power y minus 1 equal to 2 to the power x divided by 2 to the power x minus 1 negative of it dx. All variables y with dy and all variables involved, all terms involving x are with dx. This only is variable separable form. Now what? Integrate on both the sides. Now what? Integrate on both the sides. Negative sign, let's keep it outside only. Okay. Integration here can sometimes, see, integration can be tricky sometimes. Sometimes it will be tricky, sometimes, most of the times it will be easy only. Not most of the time, 50%, 50% we can say. Okay. But yeah, integration can be tricky sometimes. Here, it's not tricky also. If I ask you, what is the differentiation of ln of, or if I ask you what is the differentiation of 2 to the power x plus 1 or a to the power x plus 1, this you guys must remember, right? It will be ln of 2 into a to the power x, that means 2 to the power x. A to the power x ln x, a to the power x plus 1, differentiation derivative is a to the power x ln x. Correct? Correct, correct, correct. So basically derivative of this is this thing only, but ln 2 is missing. Correct? Derivative of this is 2 to the power y only. Derivative of 2 to the power y minus 1. Derivative of 2 to the power y minus 1 will be 2 to the power y ln of 2. Correct? So derivative of fx is over here. This is f dash x upon fx. Which form is this? F dash x upon fx. Only ln 2 is missing, so that will be satisfying. 1 by ln of 2 will divide. This will become ln of 2 to the power y divided by 2 to the power y minus 1 dy. Correct? This thing only. Now derivative of this is this. So f dash upon f ln of f. Integral of this f dash, integral of f dash upon f is ln of f. So this integral will become nothing but, I'm writing directly, this integral will become nothing but ln of mod, again mod of 2 to the power y minus 1. Mod we cannot forget. Okay, similarly this will become minus of 1 by ln of 2 into ln of 2 to the power x minus 1 plus c, obviously plus some c. Okay, this is how it is going to become. Okay, now 1 by ln of 2 plus 1 by ln of 2. Now 1 by ln of 2 we can take common, right? Inside what will remain? Ln of this plus ln of this. So that means ln of this into this. So this will become ln of, mod. Now see, mod here only we can remove actually, because x and y both are given positive. This was the reason. X and y both are positive. So this will be positive, this will be positive. So mod we can open with a positive sign. So it will become 2 to the power y minus 1 into 2 to the power x minus 1. 2 to the power x minus 1. Okay, equal to c, equal to c, equal to c, or c into ln of 2 also, like this ln of 2 also we can put over there. Or as I told you, whenever you see constant without ln and everything else is in ln, put ln of c will put over here, right? Now this ln of 2 will go that side. So this will become ln of 2 to the power y minus 1 into 2 to the power x minus 1 equal to ln 2 into ln c, or ln c to the power ln 2. We can write like this also, ln of c to the power ln of 2. Any problem in this? Right? This entire thing is a constant, yes or no? This entire thing is a constant, arbitrary constant. So can I write c only instead of this? There is no dependent variable over here. There is no derivative over here. So this is a constant, arbitrary constant. I'll write c only again. So this will become ln of, wait. We can cancel ln, no? Why did we include ln? We included ln to cancel it. We included ln to cancel it. So basically what do we have? 2 to the power y minus 1 into 2 to the power x minus 1 equal to c. Ln gets cancelled. Ln got cancelled. Ln got cancelled, no? Ln of c to the power ln of 2. This will become not entire power. This will become ln of c to the power ln of 2. Ln of c to the power ln of 2, right? Ln will get cancelled and this c to the power ln of 2 can be written as c only, right? Ln gets cancelled and c to the power ln of 2 can be written as c only. All right. Now, what is given? It is given y of 1. That means y of 1 means f of x. Y is what? F of x. F of 1 is 1. F of x is equal to 1 when x is equal to 1. Right? So this function is equal to 1 when x is equal to 1. Or we can say when x is 1, y is also 1. When x is 1, y is 1. That is a solution. That means 1 comma 1, not a solution, is satisfies. 1 comma 1 satisfies this equation. So 1 comma 1 means 2 minus 1, 1 into 2 to the power 1 minus 1, that means 1. 2 to the power 1 minus 1, that means 1. 1 into 1, c equal to 1. That means your c is nothing but equal to 1. You got the value of your arbitrary constant, right? So this thing will become okay. What do we need to find? Y of 2. Let's take another page. 2 to the power y minus 1 into 2 to the power x minus 1 equal to 1. This is what we are getting. Y of 2. We need to find y of 2. That means what will be the value of this? What will be the value of this what will be the value of y when you put x equal to 2? So 2 to the power y minus 1 into x equal to 2. That means 2 to the power 2 minus 1 equal to 1. That means 2 to the power y minus 1 equal to 3 equal to 1. That means 2 to the power y minus 1 equal to 1 by 3. That means 2 to the power y equal to 1 by 3 plus 1. So 4 by 3 equal to 4 by 3. This is what is given to us. Now 2 to the power y. This means what? Y is equal to log of 4 by 3. Can I write it like this? 4 by 3 base 2. 2 to the power y equal to 4 by 3. So I can write it like this simply. Y equal to log of 4 by 3 base 2. Correct? This thing or this thing same. Actually, to match the options, mains will always play this trick with you. It will try to check whether you can match the options or not. Okay, if you are understanding, please comment or just keep posting any emoji also you can post so that I can be sure that you are understanding. Okay, now which option matches? Tell me which option matches. Y ka value we need to find. No, y ka value is log of 4 by 3 base 2. That means log of 4 base 2 minus log of 3 base 2, right? So that means 2 minus log 3 base 2. 2 minus log 3 base 2. Option D is your correct answer. Mains will always play this trick with you. It will check. You can solve, that's okay, but it will also ask you to match with the options. It will always ask you to match with the options. That is where it is going to play the trick with you. Option D, correct. All right. Now, variable separable form. Sometimes you'll directly be able to separate the variables along with their derivatives, right? Dx with all the x terms and dy with all the y terms. Sometimes you'll have to reduce it to a variable separable form. Sometimes you'll have to reduce your equation into variable separable form. Okay, how to reduce your equation into variable separable form? Okay, before this, please revise. If last part, I'll just take a small break and come back to you. I need to go for peep. I'll just be back. Okay, stay with the session. You can revise any part if it is missing so that later part will be easier for you. I'll just switch the audio off so that Sorry if I took a little bit longer because I was damn hungry. I ate something very quickly and came back. Aha. So variable separable form we have understood. Now sometimes directly we'll not be able to see the variable separable form, right? Where variables can be separated, we'll not be able to directly see that. Sometimes we'll have to convert or reduce our equation into that form, right? Sometimes you'll have to do that. Voice is clear, right? Okay. Keep liking the session if you're there on the channel. Don't forget to do that. For example, and the best, and there are some formats in that also, this also. We saw in the starting, no, variable separable form, then linear form, exact form, and second was reducible to variable separable form. In reducible to variable separable form, there are some different types that we are going to study about. First is linear. First is linear type. For example, on one side you have dy by dx, and on the right side you have function of a linear. Function of a linear means function of ax plus by plus c. This thing you have on the right side. Okay. Function of linear means it can be anything. For example, 2x plus y divided by 2x minus y. Something like this, x plus y upon x minus y on the right side if you have. Then how to separate it, how to write it into variable separable form. Cross multiplication and all will take a lot of time. So there is a standard method how to do that we are going to look at. Let's see. Okay, so first form, yeah, this is the first form. We'll see this form first. One side you are able to create dy by dx, and right side you are able to create everything involving a linear function. Right side you have a expression in which same linear function is there. Numerator, denominator, addition, subtraction, like that. Let's see with the examples. In this case, what you have to do is, see, substitution in integration and substitution in differential equations is very much 99% similar. It's mostly similar. Mostly it is similar. So don't worry about the substitution. The intuition for substitution you'll get if you have studied about integration and substitutions in integration very well. Then here also you'll be able to do it. Not a problem at all. Okay. So if you see something like this, for example, this is a p by q only. Something like this. One side we have dy by dx, and there is an expression in which same linear function is there in the numerator and denominator. Same linear function is there in the numerator and denominator, or we can also call it f of y plus 3x. This